In this example, I'm going to use the factor theorem to determine whether or not x plus the square root of 10 is going to be a factor of this polynomial function p of x. And if it is, I'm going to go ahead and use synthetic division and divide it out. Well, the factor theorem says that this factor in the form x minus k, so I need to rewrite this just a little, so x minus the negative square root of 10. Okay, so now the two negatives here would make this positive, so now this is in x minus k form. And of course here my k is the opposite of the square root of 10. So I know this is going to be a factor if, so I have this k value now, if when I go ahead and evaluate this polynomial function at the opposite of the square root of 10, if I get 0, then that's saying that this is a factor. If I don't get 0, then it's not a factor. So let's go ahead and evaluate this function p at the opposite of the square root of 10. And so it looks like we have a lot of these x's here, so this negative square root of 10 is going to go to a lot of places and have a lot of powers. But this definitely isn't as bad as what it may seem here. Okay, so it's going to be 2 times, and it's the opposite of the square root of 10 to the power of 7, minus 20 times the opposite of the square root of 10 to the power of 5, minus 3, and then we just kind of keep doing this and plug this in everywhere that we have an x. And it looks like we might run out of space here too. So we'll kind of work here from the left and work our way to the right. Okay. So when I have the square root here to the power of 7, it means I'm going to have, well, 7 of these things, and I can pair them up because the square root of 10 times the square root of 10 makes, well, a real 10. So here's 2 of them, and I can do that 3 times because I have 7 and I'll have 1 left over. So it looks like I'll have 10 times 10 times 10, and that's going to be 1,000, and with the 2, so 2,000 radical 10. And we had a negative here to an odd power, so that negative will stick around right there. Okay, so that's that first one. And then we have negative 20. And it looks like the same thing here. We have 5 of these square roots of 10. So the same process means we'll add 2 more zeros to this, and I'll have 1 more square root of 10. This was a negative right here to an odd power, so it'll change the sign, so it'll make that actually positive. So it looks like these first 2 terms will cancel out very nicely. All right, so minus 3, and we have the square root of 10 to the power of 3 now, so we'll add 1 0 because the square root of 10 times the square root of 10. Again, following this procedure, we'll have 1 left over. It was negative, and the power was odd, so the negative will persist, so it'll change that sign to a plus right there. Okay, and then plus 2 times, and this is an even power, so this is nice. We're just going to be multiplying this by 10, so plus 20. And then it looks like we're out of powers. Nice. And then that, and then minus 24. Okay. So it looked like these 2 canceled, and then I had a positive 30 radical 10 and a negative 30 radical 10, so those 2 canceled. And I was left with 20 minus 24. So this evaluation then, when I evaluate my polynomial function at the opposite of the square root of 10, I get negative 4. So since this did not evaluate to 0, I know that this binomial here is not a factor of this polynomial function p of x. So I don't need to use synthetic division, and I'm not going to worry about continuing the problem.